So today we're going to start our exponential unit by talking about exponents. This is going to be in your book. It's chapter 8, section 1. It's unit 7 in our curriculum, and we're going to talk about zero and negative exponents. If you're sitting here thinking, we might have done this in Accelerated last year, you would be right. But we're going to walk through them all, make sure we are good. But each time our problems will be deeper and more complicated as we go through. So today we're going to simplify expressions that have zero and negative exponents. So the two rules are actually on this page right now. I'm going to show you in a second, but you're going to notice a negative exponent. This is what that equals. We'll talk about that in a second. And interestingly enough, x to the 0 is 1. So the easiest exponent rule will be your 0, but let's discover why these exist. So what I'm going to ask you to do right now is to open up your textbook to page 430, and there is a blue activity box with problems 1 to 4. The video is going to stop, and I'm going to ask you to go fill that out and see if you can start seeing the pattern. And when you're ready to go, you'll start the video again. I'll give you those answers, and we will talk about 0 and negative exponents. So basically, this is the whole table. They kind of cut it in half in the book, but this is the whole table. And so 2 to the 4th is not 8. It's 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. If you put an 8 here multiplied, really what that is adding 2. 2 plus 2 plus 2. We want multiplication. 2 to the 3rd, 2 times 2 is 4, times 2 is 8. Then you would have 2 to the 2nd is 4, 2 to the 1st is 2. And then what you should notice as we go on is you're dividing by 2 along this line, this column. So 16 divided by 2 is 8, 8 divided by 2 is 4. Do you see the pattern? 4 divided by 2 is 2, and 2 divided by 2 is 1. So notice that 2 to the 0 is 1. I'll come back in a second. And if you had done the 5s, 5 to the 4th is 625, then we go to 125, and we're dividing by 5. 5 squared is 25, 5 to the 1st is 5. And again, as you divide by 5 here, 5 divided by 5 is 1, not 0. And if we come out 10 to the 4th, oh, by the way, when we have powers of 10, that's a 1 and 4 zeros. That's wonderful. 10 to the 3rd would be 1,000. 10 squared is 100. 10 to the 1st is 10. And we're dividing by 10 here. And again, 10 divided by 10. And notice, no matter what, anything to the 0 power is 1. It's so easy. It's so easy to make a mistake, especially in a year from now or 2 years from now, where you're going to want to write 0. Anything to the 0 power is 1. Let's now talk about negatives. So I'm going to go back here. Remember, we were dividing by 2. 1 divided by 2, that would be 1/2. 1 over 2 to the 1st. And 1/2 divided by 2, if you cut half in half again, it would be a quarter, a fourth, and that would be 1/4. Oh, by the way, that 4 is 2 squared. And we can kind of see the same thing here, that 1 divided by 5 and 1/5 divided by 5 would be 1/25, which is, oh, by the way, 1 over 5 squared, and the same thing over here. And what you should notice is that when we have a negative exponent, it seems to reciprocate. It goes to the other place, and the exponent becomes positive. So 2 to the negative 2 over 1 basically becomes 1 over 2 to the positive 2. So a negative exponent, we reciprocate that base and make the exponent positive. So that's the pattern we're seeing. So your question for 1B was to look at the values that you used to replace in the blanks. What pattern do you see? And you should see that you're dividing by 2, going down this column, dividing by 5, and over here, you're dividing by 10. The second question was just to finish filling in the chart. We've already done that. The third question was, did you notice a pattern in the 0 row? And we noticed they're all equal to 1. And then finally, it was asking about the exponents. 2 to the negative 1. The exponent on this 2 is a 1. whereas 2 to the negative 2, the exponent is a positive 2. And then they ask you, what do you think would the exponent be if it was 2 to the negative 3? And it would be a positive 3. Again, reciprocated to the other place. So to kind of wrap that all up, here's the basic rules. Any non-zero number to the 0 power is 1. So any number raised to the 0 is 1. A cannot equal 0 because we really don't talk about a base of 0 raised to 0. So if you even have negative 2 raised to the 0, it's 1. If you have x squared all raised to the 0, it's 1. Any base raised to the power 0 is 1, not 0. Now here's the second rule for today. Anything raised to a negative exponent is the reciprocal of that same base to the positive exponent. So if you look right here, a to the negative n, you can picture that that could be over 1. You know, that's over 1. So you can see that it goes from the numerator to the denominator. It flips and becomes a positive exponent. And again, a won't equal 0. So let's take a look at this one. So 2 to the negative 2, you could consider that as being over 1. You're going to flip it, and the exponent changes to a positive. Now, a silly mistake people will make is just write it as 1 over 2 to the negative 2. How can that be? You know, how can 4 equal 1/4? You know, so realize that this is a negative exponent changing to a positive exponent. The base stays the same, and that becomes 1/4. Now, if that negative exponent is in the denominator, it's going to flip. It's going to go to the other place. It's going to rise to the numerator and become 3 to the second power, and think of it kind of over 1, which is 9. So again, don't make this 1/9 equaling 9, right? That's not the case. It's a negative exponent, and it will go to the other place. It will flip. It will reciprocate and become a positive exponent. And those are our 2 exponent rules for today. Now, when we're simplifying expressions with exponents, we need to make sure that there are no negative exponents in our answers, no exponents of 0 or 1. You're going to change those. We'll talk about that. Fractions have to be simplified. You wouldn't leave a 2 in the numerator and a 4 in the denominator. You would make that 1/2. And you're going to make sure you simplify numbers with exponents when it's reasonable to do so. Like we wouldn't leave 2 squared because I can make that something easy. However, if it was like 7 to the 5th, yuck, I'll leave that. So we have a 0 exponent. What's 3 to the 0? That would be 1. So we're going to take 1 times 4 to the negative 3rd. Now we have a negative exponent. We can't leave that. So I'm going to reciprocate that and put it on the bottom. So 1 over 4 to the 3rd. And 1 over 4 to the 3rd. Now let's simplify the numbers with exponents. 4 times 4 is 16 times 4 is 64. And I end up with 1 over 64. So this mess simplifies to this very nice fraction. Okay, so when I look at the next one, 2 to the 2nd, I can simplify that easily. This x to the negative 3 needs to reciprocate. It needs to move to the denominator. Oftentimes what I will do is I will draw, when I see a negative exponent, I will draw a fraction line, and I will write the number 1 underneath there. I mean, that's kind of where I'm starting. That's a huge 1, Mrs. Woodruff. Let's fix that. Sorry about that. I'll put the 1 underneath it. And then I say, okay, well, 2 to the 2nd is going to stay on top and be, 4. This guy is going to come to the bottom and become x to the 3rd. And y to the 4th has a regular old positive exponent. He's not going anywhere. So when I simplify that, the 4 is in the numerator. The y to the 4th is in the numerator. This guy is going to drop down and become x to the 3rd. So that's often a way, as soon as you see a negative exponent, kind of get your fraction line in there and realize what's going to move and what's going to stay. So here we go with this one. I'm going to do a couple more with you and then let you have some time to practice yourself. Oftentimes, people will make a mistake and include this 2 with this negative 1 exponent, and they'll bring it down. This 2 has an invisible 1 exponent. he has a positive exponent. He's not going anywhere. But the a to the negative 1 is. So again, if you kind of come over and make your fraction line and then ask yourself who's staying and who's going. The 2 is going to stay, but the a to the negative 1 will drop, reciprocate, and become a to the first on the bottom. The b to the third is positive. He stays put. But the c to the negative 2 will reciprocate and move to the denominator and become c to the second. The 2 stays, a to the first on the bottom. The b to the third stays, 6 to the second on the bottom. Now there's one more thing. That a to the positive 1, we're going to make that 1 be the the invisible 1. So notice I didn't write a positive 1 here. C to the 2, b to the third, a to the first, but make that exponent of 1 an invisible 1. Don't write that exponent, and then c to the second. Okay, here's a big mess. What happens with the number negative 3? Does it reciprocate? And the answer should be no. His exponent is the invisible 1. Just because he's a negative number, we don't just wing him down to the bottom. He's a negative 3. It's an exponent that's negative. Did everybody hear that? The negative 3 isn't going anywhere. His exponent is the invisible 1. How about the p to the negative 2? Will that move? Will that reciprocate? And the answer is yes. That's going to come to the bottom as p to the second. What about q to the first? He's going to stay put, and I'm going to make that the invisible 1. Let's go to the bottom. Is this guy going to move? He has a negative exponent. He's going to rise and have a positive exponent. What happens to s to the 0? That becomes a factor of 1. And when I multiply by 1, he kind of is just going to disappear. How about t to the second? He has a positive exponent. He stays put. Let me show you the answer and make sure you understand what happened. Negative 3 stayed put. P to the negative 2 went down and became p to the second. Q to the first stayed, but we made him the invisible 1 exponent. In the bottom, r to the negative 3 rose up and became r to the positive 3. It reciprocated. This guy, remember, came down from the top, and the t squared stayed put. All right, let's move on to number 5, and then I'm going to give you a chance to do some practicing. First of all, when you see this negative exponent, one way to sort of start off and make this extremely easy is remember that a negative exponent reciprocates everything. It makes things flip. So I could get rid of this by flipping everybody inside. So the g to the negative 3 became the top, and the e to the 0 f squared became the bottom. And I no longer have to, this is all to the first power. So this negative right here made this whole thing just flip. So I don't have to look at that anymore. Now this becomes kind of like what we did here. Do I move this guy? And the answer is yes. He's going to go to the bottom and become g to the positive 3. The e to the 0 becomes a factor of 1, and 1 times f squared, the 1 is going to look like it just disappeared. And does this f squared move? The answer is no. He has a positive exponent. So what got left on the top was a factor of 1 over f squared times g to the third. So that gives you an idea just how to work with 0 exponents and negative exponents. So now what I'd like you to do is we're just going to walk through each one of these. Video stops, you check yourself. So can you simplify number 1? Okay, so notice the word actually was evaluate. So did you realize that he has to go to the denominator and become 1 over 3 to the 4th? Now evaluate, we can give a better number than 3 to the 4th. 3 times 3 is 9. Times another 9 basically is 81. Did you get 1 over 81? Okay, do number 2. In this case, this guy stays, but this one is going to drop to the denominator and become a positive 4 exponent. And you're going to have 7 to the 4th over 7 to the 4th. And anything divided by itself is 1. Well, that's really neat and clean. All right, on this one, try number 3. 4 to the 0 is 1, and 1 times anything, I really don't need to write that because it'll just be the anything, the 5 to the negative 3. Did you write the 5 to the negative 3, reciprocate it, and write it as 1 over 5 to the third? And now we're going to evaluate 5 to the third is 5 times 5, which is 25, times 5 is 125. And how about the next one? What I would do is simplify this expression first, and then substitute and then simplify your number. So the 4 stays put, the x squared stays put, and the y to the negative 3 will go down, and you'll have 4x squared over y to the third. 4x squared over y to the third. The x is going to become a 3. 4 times 3 squared all over negative 2 in parentheses raised to the third. Did you get a negative 9 over 2? You'd have 36 over, and the negative 2 to the third would be a negative 8. You'd have 36 over negative 8. Simplify it, should get negative 9 over 2 by dividing by 4. Next one, simplify it. Did you get y to the fourth over x squared? Next one, simplify it. This time, the negative 4 is part of that negative. So he's going to go for a ride, and we're going to start by putting 1 over negative 4x to the negative third. And that negative 4 is part of the third. So negative 4 to the third is negative 64, and then x to the third. So all of this went to the bottom first, 1 over this to the third. And then you took negative 4 to the third power, which is negative 64, and x to the third power. How about this one? The whole thing is going to drop, and you're going to have 1 over 3xy in parentheses squared. But you can simplify that. Square everything there. 3 squared is 9, x squared is x, and y squared to the second power is y. Number 8. Did you flip everything first? So the 2y to the negative 1 is on top, and the negative 3x squared is on the bottom. And the only thing we really have to worry about is that negative exponent. So the 2 is going to stay up on the top, but that y to the what was negative 1 is going to drop to the bottom and become y to the first, and we write that as an invisible 1. And the negative 3x squared just stays down there. Remember, a negative 3 stays put. It's when it has a negative exponent. So this negative 1 flipped everybody. The 2y to the negative 1 came up top, and the negative 3x squared went to the bottom. And then we moved the y from the top to the bottom because of his negative 1 exponent. Okay, let's move on to do a couple backwards problems. So what exponent would simplify and give me this? So what you should have first realized is that the y somehow went down. He went to the denominator and became a 3. Did you put that needs to be a negative 3? So the 3 has a positive 1, stays put. The x has a positive 1, stays put. And the y to the negative 3 would reciprocate him to the bottom and make him y to the positive 3. Okay, what exponents do I have to put in here to get this? Where'd the a go? Well, a to the 0 would be 1. How did the b rise up? It had to be, and become a 3. It had to be a negative 3. So when this guy, so this is equal to 1, and when the b to the third came up, 1 times b to the third is just b to the third, and the 3 never moved. So basically today, what we are talking about, guys, is 2 exponent rules. The 0 is easy peasy until you go forward a year and forget and put 0. Anything to the 0 is 1. The negative exponent is the tougher one. And the rule, the definition of a negative exponent, if you would have it, is that it reciprocates and becomes a positive exponent. So if it's negative 2 on the top, think of this over 1, it goes to the bottom, to the denominator, and the exponent changes to positive 2. If it's negative in the bottom, in the denominator, it rises up and becomes positive. And remember, this guy could be written over 1. So now it's time to kind of practice and see how we do with these two rules. As we move forward, we are going to add a new rule. First, we'll do a little bit of what's called scientific notation. Again, should be a review, but we're going to do a reteach on that. And then we will start adding 3 other rules. And by the time we're done, we will have 5 exponent rules. I will see you in class. We'll check out how you did, and we'll do some more practicing together. Have a great day, everybody.